lecture, we will talk about computer graphics. When we talk about computer graphics, we focus on the application level, meaning that we will talk about different software that we can use for creating computer graphics. So you may ask, what is computer graphics? Basically anything related to the generation or display of images using a computer, that is computer graphics. For example, displaying a bar chart on your computer requires computer graphics. And showing all the fonts on your computer also requires computer graphics. So these are some examples of computer graphics. For example, you may be doing photorealistic rendering, meaning that you want to render some realistic 3D scenes using computer software. You may also be using computer graphics for technical illustration, meaning that you want to build technical model using software like AutoCAD for illustration. Computer graphics can also be used in medical visualization to diagnose diseases. And also in science, you may use computer graphics to visualize the structure of complex objects. For example, visualization of molecules and DNA in biology. Nowadays, computer graphics is heavily used in video games and also movies. So on computers, there are two types of graphics that we can use. The first type is bitmap image. It's based on pixels. So if you zoom into the image, you will see all the pixels within the image. The second type is vector image. For vector image, basically all the objects inside the image are represented mathematically using equations. It's perfect in terms of quality because all the objects are represented continuously using equations. And you can easily make dynamic changes by modifying the equations. It's often smaller in file size comparing to bitmap images because you just have to store the equations rather than the pixels. And this is an example of how we can draw a curve using this equation. This is another comparison of bitmap image against vector image. For bitmap image, you see all the pixels. For vector image, it's finer because the circle is represented continuously using equation. So first, let's focus on bitmap image. We know that bitmap image is based on pixels, and basically a pixel is just a point in your screen. It holds a color value, and the computer display, meaning the monitor, is made up of a number of pixels. If you're talking about the resolution, it refers to the number of pixels in the two dimensions, one for the columns, another one for the rows. And you can see some example resolution in the slides. For example, 800 by 600, 1024 by 768. So notice that the definitions of resolution are slightly different on different media. If we are talking about a computer display, we are talking about the number of pixels in total they can display. If we are talking about a camera, then we are talking about the number of pixels they can capture. If we are talking about the resolution of printed material, then we are talking about the number of pixels per inch on the printed material. For the human eye, our retina display is approximately 328 pixels per inch. And basically the rule is that the higher resolution in smaller size, the more realistic and sharper the image. So here we have some example resolutions. And you can see that basically the higher the resolution, the sharper the image. The sharper the image. In computer graphics, there are different software techniques that we can use to enhance picture quality. One very common technique is anti-aliasing. It uses different shades of color to reduce jagged edges, and is especially effective for text, as you can see in the diagram. And this is another example of text before anti-aliasing and after anti-aliasing. So we know that for bitmap image, each pixel holds a color value. And the most common way to represent the color values is by the use of RGB. So by mixing different amount of red, green, and blue, we get different color. And if we are talking about true color, then we are using 24 bits, 8 bits for red, 8 bits for green, and another 8 bits for blue. So it provides more than 16 million colors. So for a true color image of 800 by 600 pixels, it requires at least 1.44 megabytes of storage. When we are showing images using RGB, we assume that the background color is black. For example, computer monitors and TVs. So if we don't have any value for RGB, that means 0 for red, green, and blue, then we have the background color black. If we have the maximum amount of red, green, and blue, then we have white color. This is a table showing different color depths. That means the number of different color representations and the corresponding storage required. And basically, if we use more colors, we get better quality image. So another way to represent color is by the use of HSV. So when we are using HSV, we have to specify the hue, which is the base color on the color view. And also we have to specify the saturation, which is the color purity or the amount of white color. And then we have to specify the value, which is the intensity or the brightness of the color. And it's commonly used in computer graphics applications, for example, Photoshop and GIMP. This is an example of how we can specify a color using HSV. So first we have to pick a base color on the color view as H, hue. Then we have to specify the amount of white color using saturation S. After that, we have to specify the intensity or the brightness of the color using V. This is another example of picking a color using HSV in GIMP, which is an image editing software that you use in the lab. If we are talking about background in black, then we can either use RGB or HSV to specify colors. But if we want to print things on papers and the background color is white, then we have to use cyan, magenta, and yellow, CMY. In theory, if you don't have any CMY, then you get the background color white. If you're mixing the maximum amount of C, M, and Y together, you get black. But usually you get muddy black instead of pure black. So that's why usually there's an additional blacking for black color. And CMYK, K means black, is commonly used in ink cartridges for printer. Now we'll point out some popular graphic editors. For example, Microsoft Paint, which is part of the Windows accessories. Adobe Photoshop, and you have to buy a license for it, which is very expensive. And also GIMP, which is the one that you will be using in the lab. Using Photoshop or GIMP, we can easily make changes to images. So can you see what has been done to this image? So basically we have removed the red bird and also convert the image to grayscale. So can you see the difference between these two photos? So basically all the surrounding people, they were removed before the photo was released. By using Photoshop or GIMP, we can easily copy and paste different things on different backgrounds. This is another example showing that we can easily move the kid to another background using Photoshop or GIMP. You can also apply different special effects using graphic editors. This is an example of using special effects for makeup. Now we'll talk about different image file formats that we can use for storing images. We'll talk about Bitmap, GIF, PNG, JPEG, and SVG. So first we'll talk about Bitmap. Bitmap is based on RGB in 24 bits. So that means true color. So you can consider it as a raw file without any compression. So it doesn't support animation, and it also doesn't support transparency. So now let's talk about GIF. GIF is having a lower color depth comparing to Bitmap. It only supports 256 colors. It supports lossless compression. That means that after compression, you keep all the original colors in the original image. It supports transparency. That means that it's good for creating icons for web pages. And it also supports animation, as you can see in the video. PNG was created to replace GIF. It allows true color, that means 24 bits. It also supports lossless compression, and the compression ratio is even higher compared to GIF. It supports transparency, so that means that it's good for creating icons for web pages, but it does not support animation. JPEG is the most common format that you can use for computer graphics. JPEG support true color, that means 24 bits. It supports lossy compression, that means that after compression, you may lose some color information. But the good thing is that the compression ratio can be really, really high. That means that the file size is going to be small. It doesn't support animation, it doesn't support transparency, and it's mainly used for storing photos. These are some example JPEG files with different compression ratio. So you can see that after compression, you may lose some color information. And I would say that at around 50%, the quality is still okay. The last format that we'll talk about is scalable vector graphics, SVG. From name, you know that it's a kind of vector image. That means that all the objects inside the image, they are represented mathematically using equations. Since all the things are represented mathematically, it's very good for animation and interaction. So that's why it's really suitable for game development. This is a little comparison of vector image versus raster image, which is based on pixels. And you can see that for vector image, since all the things are represented continuously using equations, is much finer and smoother comparing to raster image. In order to create good images, you need good tools. For example, Photoshop or GIF. You also need artistic skills and also lots of patience. In Com 101, you will learn how to use GIF to create images in one of your labs.